Hey guys, welcome to a Friday night free-for-all. I was going to call it Friday Night Restoration, but we're not going to go quite that far, I don't think. We're going to try doing two things. One, put a base back on this damaged cathode ray tube, and then try putting it into a chassis I picked up at the Early Television Foundation a few weekends ago. I believe the chassis is 100% original. It's from an Emerson 639 electrostatic set. Now, I'm not going to call it a Friday Night Restoration because we're not going to have time to go that far. And I don't want to steal anybody's catchphrase, so let's just call it, let's just have some fun. I've talked about repairing picture tube bases, in particular for a 7JP4, a while ago, but it's been some years since I talked about it or had to do it, so let's go over the issues here. First off, why does this happen? Because it is a fairly common problem. Well, it happens because these are big neck, big 14-pin socket. Two are unused, but we still have 12 pins left. That puts a lot of force between the base and the plug that it goes into. And if you're not careful, if you just go and yank on the plug, all that force tends to rip these off. They do use the usual adhesive between glass and a Bakelite base like tubes do, but over time with the heat, expansion, contraction, and again all the force being put on it, they rip off. And there's not a whole lot holding these pins, these wires into these pins. So these pins are hollow, and the wires coming out of the CRT go right through the glass, and they're tinned just on the very tip. And so they pass through these hollow pins. They just put a little solder blob on the end. So you might think, well, there's a good half-inch soldered on there. No, it's just barely a little bit at the end. Sometimes even when these are attached, there are problems because you can get cold solder joints, and you need to go through and touch these up. Alright, so I bought this cheap off of eBay because it was untested, unknown, damaged condition. I got paid 20 bucks for it. The getter is essentially gone, but I did clip on some leads and test this with my Sencor CR70, which can do electrostatic oscilloscope type CRTs. And it does have emissions, and it didn't have shorts, and I think I got a little spot on the face of the CRT, so I want to go ahead and put the base back on. Now that was about a year ago. Hopefully it's still good. But regardless, I thought it'd be a good exercise to go through. If we can't get this working, I do have other spare CRTs so we can proceed with the chassis. So how do you get it back on? Well, luckily none of these wires are broken off. I don't think this is pure copper. I think it's some type of special alloy that has the same coefficient as the glass. Otherwise, where this metal passes right through the glass, over time you would develop cracks. So I think that's why it's a little bit difficult to solder to. And also, since they only tin the tips, the remaining wire over time has developed some oxide layer, I think. So if you were to try heating this up and tinning it, it really doesn't work. I mention that because, well, unless you have godlike abilities, you're not going to be able to straighten all these wires out and just push this back on. So I attach extension wires to them. So I need to have tinned wire and tin the ends of these and connect the two. I've tried a few different ways, and my latest approach is I use desoldering braid and clean out all the pins. And it turns out the wire from old telephone wiring systems with the insulation on will slide through like so. It's not a whole lot of clearance, but there's enough. In the past I stripped all the insulation off, but this time I just did the tip. So, the idea is we pass a wire through each of these hollow pins, strip the end, tin it, and attach it to a pin, the corresponding wire that's protruding from the CRT, and then Once we get them all attached, we slide this home, and then we go through and heat up through all these pins, and these wires should fall off, and then we can flow some solder down into these hollow pins and establish a good connection to all of them. Sounds easy enough. In practice, it's a little tricky, because what typically, or what can happen, is because there's only a well, the wires can, the solder connections can come loose. There are, I believe, 11 of them. 3 of these pins are not used. So as we do each one, and this fluxes around a little bit, some of these can snap off. Now, why would I want to just connect it like tip to tip? Because these leads are already the perfect length to go right to the end of these hollow pins. If I was to say, maybe make a corkscrew out of these, I could slide it over this and attach it more firmly, but then I wouldn't be able to snug this down all the way. So another technique that I have done is to cut about 1/4 inch off of each of these, and then you have to clean this with some, say, fine sandpaper to get it solderable, and put a corkscrew on each one of these, or a little squib, and attach the extension wires like that, so they're on there very securely. That's tedious. Every time you flex these, you risk breaking them off at the glass junction, so I'm going to try doing the more fidgety technique. It's frustrating, requires patience, requires a steady hand, but I think it's a cleaner way to do it and puts less stress on this. So let's get to attaching some extension leads. I want to get these both situated so they're about the same height, so when I run the wires through, everything is lined up without putting stress on anything. Okay, all 10 wires have been tacked on after threading them through the base. Now the trick is to slide this on without any of these breaking off. If they do, we just, well, try again. Oh, one broke off. Yeah, I noticed that one didn't adhere too well. I think I'm going to get a razor blade and scrape that off a little bit and touch up the solder and keep going. Alright, I had to touch up a couple of the wires, and then I just quickly shove this down, and I think we're good. I think we're good, as long as none of those wires are broken off inside. Tell that by tugging on them. Yeah, I think we're good. Just need to go on a little bit more though. I'm kind of wiggling things. I'm going to try removing some of these. Some of these are all the way through, some aren't quite there yet. Going to get these last few wires off and then peer down each of the hollow pins and make sure that the wire's coming up through like it should. Last one. Alright. Doesn't quite want to seat down all the way. So one of the wires is hung up. Well, it's on, but it didn't seat down quite as firmly as I would have liked to have, or I would have liked it to. but it looked like all the wires were making it up, so I flowed solder down into the pins, and I proceeded to hook up my Sencor tester. We do have filament glowing, so let's see if we actually have some emissions. Cutoff control is a little crazy. We do have emissions. And I do see a spot on the face of the CRT. So that is excellent. Okay, we do have cutoff control. It's just kind of squirrely. Let's see. I'll give you guys a shot of what I'm looking at. Okay, I killed the overhead lights coming in on the side of the CRT, and when we get in close, there's a spot on the face of the CRT, and if I vary the cutoff control, I can vary the brightness. So that's good. What I don't know is that all 4 deflection plates get hooked up properly. So I'll throw some electrical tape around the base to secure it, and let's pull out the Emerson chassis and take a look at it. Here is the TV chassis. It is for an Emerson 639. It's a little electrostatic TV. And one of the more interesting designs, because it can run on AC or DC. 105 to 125 volts AC or DC to be specific. Just has one single rectifier, this orange selenium down here. It's a floating chassis design. Power switch switches one side of the plug, which goes to the common, and the other side goes to the rectifier, and the filaments are 2 series strings. So here's where your power comes in, AC or DC. There's our switch, which goes to this sort of star B minus here. This is your negative return, which is not the chassis. Chassis is floating, so it's not really a hot chassis set. But it is an unpolarized plug. And here are the 2 filament strings, 300 milliamps each string, and they join together with the picture tube, which takes 600 milliamps. And here is our rectifier. So we have a 2.5 ohm current inrush current limiter resistor, rectifier, 2 electrolytic caps, 120 microfarads with a filter choke, and that powers the set. So it's rather unusual for a set to just run off a single B plus supply that low. Usually they take a couple hundred volts. Usually there's a doubler in there, but they did it. Enough of the downside. I looked at the service info and I compared this to a reference photo of another chassis. I actually have another one of these. The other one I have is corroded on top. I think some rodents were in there, and that's why I wanted to buy this. However, my corroded, nasty one appears to be all original. When I compared it to this, I saw a number of things that had been done. For example, this cap has just been tacked in. This is a replacement for one of the 120 microfarad sections. So the original electrolytic, I presume, was bad. It looks like all of the high voltage caps have been replaced. There are 4 6,000 volt caps down in here. And these 2 green caps up here are replacements. I don't even see a cap up here in my other reference photo. That aside, it looks to be pretty much original. I was surprised the tuner apparently is supposed to be like this, where the bottom half is exposed. This is one thing that makes it a little bit better design, is that it has a full-blown tuner like you'd find in a bigger console set. There is a piece missing though. There should be a piece of stiff wire securing the back half of this drum in place, and it's gone. So assuming this set gets running, I'll probably have to apply a little bit of pressure here. It's kind of hard to get in there and replace that wire without taking the whole tuner out, which I don't want to do right now. So one good thing is that there's just a single rectifier. So if we hook this up to a voltage source and a variac where we can vary the input voltage, we can easily do a slow power up. If I used a vacuum tube for a rectifier at really low voltages, the filament doesn't have enough juice for the diode to start conducting effectively. However, it is selenium, so I have had one of these go up in smoke. It's very unpleasant. I don't have a whole lot of ventilation out here in the basement, plus it's cold, so I wouldn't want to open the windows anyways. I'm going to go ahead and replace that with a silicon diode. And, you know, I'll leave the rest. These repairs were done a long time ago, probably about almost as old as the TV. Let's see what happens, keeping in the spirit of this. The filament strings do not quite add up to the full supply voltage, so there are some dropper resistors. I believe one of them is right here. I'm not sure where the other is. But one thing we can do is I can disconnect that rectifier, power the setup. We can see if all the tubes light up. I don't know anything about this chassis other than I bought it for 10 bucks at the swapfest. All the tubes appear to be here. The high voltage generator's inside this box. There's just one screw left holding the lid on. There is an RF oscillator in here using a 25L6 that powers an RF high voltage coil. That's what makes the high voltage that powers the CRT, which we will need to hook up as well. It gets held in with this band. The original bit of cork that cushions it came loose, but it is here, so we've got that at least. So let's get that going. Just lining up the keyway here. Now, if you're not experienced with vintage TVs, I don't recommend you just go ahead and do something like this without familiarizing yourself with the design and checking components a little more thoroughly, checking the wiring. One thing I do have in my favor is that I have a Suncor Suncor PR57. I'm going to hook this up to base. It might loose, which does have a circuit breaker and a fuse in it, so that will offer protection in case something is shorted out. I need to find a screw for this to secure the CRT in place. So I'll get this strapped down. I'll get a voltmeter out, I'll get my Variac PR57 out, and get things set up for a power-up. I clipped out the selenium rectifier. CRT has been installed, plugged in a cord for power, made sure all the tubes were seated, and I've already turned on the set on the control up front here, and it's plugged into my PR57. So let's turn it on, and hopefully two things will happen. Tubes will glow, and we can check the current draw, which should be 600 milliamps if both filament strings are intact. Here we go. Look at that. Settling into just about 0.6 amps. And That means all the tubes have to be glowing. They're series strung. If something was out, we wouldn't have full clearance draw. So, oh yeah, isn't that pretty? Isn't that pretty? Talking about the CRT filament, it is glowing, but at least the 7JP4 is being a little bit brighter than that. Okay, well, we'll see how it goes. And I wouldn't be I wouldn't be all that surprised or bummed out if it doesn't produce a good picture. But I have others. Okay, now I'm going to tack in a silicon rectifier and try powering up at reduced voltage. Also pop the cover off the high voltage generator so you can see what is down in there. It's a 1B3 high voltage rectifier and a step up type coil to produce the high voltage. I have installed a 1N5408, that is a 3 amp 1000 volt rated diode. Way overkill, but it'll certainly be up to the challenge. I left everything else as it was. I did note that this new electrolytic was tacked across the original. Not exactly the correct procedure. You should disconnect the original, but we'll just leave it in place for now. Voltmeter, I believe I have at this point after L5 the filtered choke, so that should be the B plus plug into the whole set. I have my Variac turned down to just around 20 volts, so here we go. So far so good. So this B plus, I don't spec it on here, but it's probably around 130 volts or so. That's all the set runs on. So the idea now is to slowly increase the Variac and monitor the current draw, monitor the B plus voltage. I can switch my Variac to current mode. Right now we are about 0.275 amps. The set draws a little under 1 amp at full power, I believe. Alright, so I seem to be pretty stable around 29 volts. Let's go up a little bit. Now, those of you used to using a dim bulb tester, that's essentially what this does. This will limit the current in case something goes awry. Also an isolation transformer, crucial when working on transformerless sets. This set does have a built-in speaker, so when we get enough voltage for tubes to start conducting, we should hear a crackle. I have the volume up all the way. Things seem to be holding pretty steady. Let's go up a bit. It's been about 15 minutes. I'm up to about 80 volts. Still no signs of life, but everything's holding pretty steady. It's now feeding in about 92 volts AC. Ah, there is some action out of the speaker. Getting the crackle. Let's keep going. I would be surprised if we actually get high voltage. Because these high voltage caps tend to get really leaky and they would drag everything down. So we're feeding it out. We're almost at the threshold that's supposed to start operating is at 105 volts, and we're at about 100 volts. But our B plus is pretty low, so I got a feeling things are loading this down more than they should be. Okay, we're at about 105, so the set should theoretically be able to work at this point. Alright, now the little 6,000 volt probe that comes with the Fluke 27. If we have any, I should be able to pick something off here. We have some, but it's pretty pathetic. Like 230 volts. It should be in the neighborhood of 5,000. Well, let's juice this up a little more. Up to 115 now, coming in. Nope, no change on the high voltage at all. So either the RF oscillator that drives that RF high voltage coil isn't running properly, or these leaky caps are really dragging it down. I'm more inclined to think it's the latter. How do we find out? Well, we could replace them. The main one I would want to try replacing is the one that actually filters it rather than the coupling cap. So I'm talking about, oh, there's two. These guys. So there's one inside the box that says 0.0005. That might be ceramic. But this would be the main one out here, 0.005. And it looks like the coupling caps, you have a couple 0.001s. Where are the others? So that's for the horizontal. The vertical should have some 0.0. Oh, here they are. So the verticals are 0.005 and the horizontals are 0.001. That's pretty standard. So there's 5 high voltage caps in all, 1 to filter it and 4 for coupling. I suspect the filtering one is this big yellow guy that's a replacement that's up front. Indeed, this was the main high voltage filter cap in here. I replaced it and made 0 difference. I swapped the 25L6 that drives the high voltage coil with one from the other side of the chassis. Really made no difference whatsoever. So now I'm switching my attention to the tuner, because hey, maybe we can at least get some sound out of this set. So I unmounted the tuner and disconnected this one cap going to the chassis so I can rotate it a bit. And this is where the problem is. There's supposed to be a stiff wire going from there, wrapping around that and going to there, and then it gets greased up, and that's what holds this drum in place. Well, I just happened to be given an Admiral parts chassis at the same swapfest, and I just popped that piece out of the other chassis. So that simply wraps around one of these ears, and then you need to bend it up and slip it behind the one on the other side, or perhaps it goes this way. I don't think it really matters which way it goes, but this does appear to be the right size. And that's surprising, because these tuners, I believe, are made by Sarks Tarzian. I'm probably butchering that, but it's a third-party company that made tuners, and a lot of sets use them, and they have a very distinctive appearance. Admiral used them in all their sets for years, and I've been seeing them in a few other sets as well, including this Emerson, which is nice as I have a number of ones I've salvaged out of sets, so I have spare parts. So each channel gets 2 replaceable components here, and on the other side of this are some inductors and capacitors, and that's what tunes in the local oscillator and bandpass filter to lock in the channels. These little metal contacts press up against these fingers up here as you rotate the drum around, and that completes the circuit and locks these components for each of the channels. That makes that lovely clunk clunk sound as you rotate it around. Thanks due to that roller wheel down here, which has a very stiff spring on the other side of it. Alright, powering up with the repaired tuner, and I have a channel clunker knob on there. No, there are no analog broadcasts for TV, but we do have an FM radio station, Me TV radio, on channel 6, 87.7 FM, which this should be able to pick up. If the tuner's working and the sound IF is working. I just don't know what channel 6 is. So it comes in handy that they have those channel numbers marked on. Alright, so we are on 9 or 10 right now. This is 6 or this is 6. Fine tuning is really stiff, so I don't manually manipulate that. We obviously are not getting anything. Well, that's something. That is the 6S8. So detector, AF amplifier. It's basically the FM detector. So that's doing something. That's good. Now the B plus is low, even though I have about 120 volts AC going into this. It should be about 130, and it's about 112. So I suspect that the filter caps are still are very leaky, maybe won't fully form up, or something's loading down the circuit too much. So that's going to affect the performance somewhat, but it shouldn't be this bad. Probably it's all the leaky paper caps en masse contributing to all these problems. Sometimes you can get a set to do something. Usually you can get the receiver to work, because most of the components, like in the tuner, there are no paper caps. So I'm not surprised that that's doing something. I'm getting some change to the hiss as I rotate through it. And in the IF, there aren't very many paper caps. There are a lot of paper caps in the sweep circuit, the sync circuits. So I'm not surprised that those are not working. So where the heck do we go from here? I didn't want to open up the high voltage box, but I ran out of things to check pretty quickly because there just aren't that many components. 25L6 drives this coil, and underneath here there's basically one resistor and one capacitor. The rest of the parts are inside here. It's not just a coil. We have 2 resistors buried in this terminal strip, and we have another resistor here, trimmer cap, and of course the windings on the coil itself. Basically there's a primary, secondary with a lot of windings, and then a little tickler feedback coil to keep the oscillations going. Alright, so with that opened up, I can check everything. Now, why didn't I want to do that? Well, the cover is held on by screws around the entire perimeter of the base, and guess what? When the CRT is installed, you can't get at half of them, so I had to take the picture tube out again. What I'm going to do, because I don't want to keep taking it in and out, I am going to sub a resistor in for the CRT filament so I can power this setup without the picture tube being in place. And then we can just simply test to see if we have high voltage. Once we do, I'll put it back in. Well, okay, so I want to check these resistors, and I notice this base is loose. That's not good. We can tighten that down. Check for continuity, but I think I may have found the problem already. High voltage rectifier tube. It's not looking so good. It's milky at the bottom, like air has gotten inside and eaten away at the getter, and the plate looks corroded. Like, so maybe air has been, and moisture been getting in here for a long time. It's unusual for these to fail, but not impossible. I certainly have plenty of spares, so that's not a problem. I'll dig another one up. It's been in here for a very long time. I had a hard time getting that plate cap off. I had to pry it off with a screwdriver. It's Sylvania, not Emerson, so I don't know if it's the original. Some of these other tubes are Emerson, and I suspect they are the original. They might have used the Sylvania tube. This could be the original tube. I suspect it is later, though, because it's a 1B3/1G3, which is a later type. But who knows? Who knows? At any rate, a little spider colony egg thing down in there. It's also a little bit crooked. I'll dig up a replacement. These are notoriously hard to test. Basically, since they're so plentiful and inexpensive, because basically nobody would, except the weirdos into vintage TVs, have much use for them, so I'll just replace the thing. I dug up this very nice looking RCA old school type, just a 1G3. Notice it's a bit taller. I have that installed. I haven't checked the old one yet. I'm just going by the way it looks. It looks pretty bad. And threw in a 10 ohm resistor to substitute for that tube filament. And here we go. High voltage probe. I'll just probe from this side. Meter in volt mode. Speakers. If it's going to work, it should be working by now. Oh yeah. About 5,000 volts. Nice. Glad I didn't waste any more time underneath the chassis screwing around. I honestly was really not expecting that to be bad, but I'm glad that's what it turned out to be. Cool, so we should get glowing on that CRT if the repair was successful. Alrighty, CRT reinstalled. Power is on. And on the brightness control. Verify with my meter that we have high voltage, 5,000 volts. Not seeing anything there. So even if the sweep circuits are dead, get a dot in the middle of the screen. Well, that's a little disappointing. Oh, hey, whoa. Oh, brightness works backwards. Counterclockwise is bright. Alright, go figure. Let's see. So we have two centering controls. Okay, that's Horizontal centering is working. Fantastic. That means both deflection plates horizontally are connected. Vertical. So it's not going all the way down. It could be one of two things. One, these high voltage circuits are notorious for having resistors or controls go a little flaky. Plus, who said the deflection circuit's working fully properly? But if only one deflection plate was hooked up, it's possible you could just get half the screen lit up, kind of like it is now. Well, let's see. The controls do. Okay, there's width. Width is actually working. It's some bad ringing, but it's working. This control is kind of frozen. Okay, that must be height. Or vertical hold. And I don't know what this is. It's not doing anything. Might be horizontal hold. I dug out my B&K 1077B, which has been packed away for far too long. This is arguably the most useful piece of equipment you could have when it comes to troubleshooting a late 40s, early 50s TV. Aside maybe for your brain and a multimeter. Mine needs an overhaul. I should do a dedicated video just on this, about how it works and what it can do, but for now, suffice it to say, it can generate any signal we might want to feed into this set. So signal injection. We can do an RF into the antenna input, we can do IF into any IF stage, we can do video into any video stage. So just like troubleshooting an amp where you don't have any output, we're going to start at the last stage, so the final video amp right before it drives a CRT, and inject a signal to the grid. If we get an image, we'll go to one step back, and then one step back, and keep going back. There's 2 video amps as a detector, 3 IF stages, and before that the tuner. So I was studying the schematic. It's horribly laid out in the riders, but at least it's all on one page. I finally realized the second video amp is a 25L6, which is an odd choice. They use a number of them. They use 3 of them in here. They use a 25L6 to drive the RF oscillator for the high voltage, 25L6 for the horizontal amplifier, 25L6 for the video amp. I'm most used to seeing a 25L6 as an audio amplifier. Very versatile tube, apparently. Before that, we have a 12AU7. Half of it is the first video amp. So we can inject composite video into either one of those grids. Before that, we have 6AL5 for the detector. And before that, we would need to have RF modulated video. The IF frequency in this set is around 21 megahertz. So anything in the first, second, or third IF stages would have to be modulated. Before that, it would need to be RF. So if we're on channel 3, it'd be, I don't know, 50 something megahertz, as memory serves, for the modulating frequency. This can do it all. We're going to start out with video. Also critically important, because this is as hot on the B-, and this is a grounded device. We cannot connect the ground on this to the B- on that, unless we run it through an isolation transformer. So both these pieces are critical to be working on this TV. Oh, alright, well, why do I can see there's an image? That's cool. I've got the output of my B&K at max. If I go back a stage, I imagine I'll get more gain out of this set. Let's see, also... Okay, this... Actually, I'm not sure what controls are what. I think this is contrast. I don't know which of these is horizontal and vertical hold. Okay, I'm going to guess this is... Okay, that's horizontal size. Probably. That's height. Probably. Oh, and then there's focus and centering. Where the heck are the hold controls on this thing? Oh, these two knobs. This is horizontal hold. Okay, so horizontal's locked. This is vertical. Isn't that a thing of beauty? Might have the polarity inverted? I get nothing if I go the other way. Whew, what a mess. There's brightness. Still don't get why brightness works backwards. Somebody replaced the control and wired it up wrong. Having problems with the vertical doesn't surprise me. That uses larger value caps. It's more sensitive to caps going south. So that perhaps that's why I should. Well, let's go back a stage next. Let's focus on why we're losing things. Oh yeah, sound. Do we have sound? No, of course, no. If you use the composite video, there's no sound. When we do the IF stage, we should get sound. But let's go back an IF video stage first. Let's go to the grid of the first video amp. Okay, now we're injecting into the third IF stage. So I switched my B and K. I'm not using the RF output. Now I can dial in the IF frequency here. And we're not seeing anything, but let's see, I'll put the level up all the way, play around with the frequency a little bit. Nothing. I hooked it back to the grid of the first video amp just to make sure that the set was still operating. And yeah. So I am going to focus on the detector, and while I'm at it, I'm going to work on the vertical circuit too. So vertical circuit. There's a vertical oscillator, 12SN7 rather, dual triode, 6SL7 vertical amp, and that drives the deflection plates directly. I think I could place to start is to do the large value caps. There's a 0.1 microfarad in here. I started out by checking the vertical amp, the 6SL7, and I noticed right away that some work had been done in this area where there's two 10 meg resistors and also a 22 meg resistor on the grid going to ground. Those had been replaced, and the terminal strip that the two 10 megs attached to is broken off. Here's the replacement 10 meg they had put in, which was just a dinky little half watt, and here's the original 10 meg, which measures open. There is a lot of voltage on these. Resistors do have a voltage spec. When you exceed it, they can have voltage breakdown. They can develop carbon tracks, in particular with carbon comp resistors. So a half watt is not sufficient. That's why they used a 1 watt. It's not that they get hot. It's you need superior voltage rating. I believe a half watt is 350, a 1 watt is 500, and a 2 watt is 750. And that carries over into modern times as well. Now you might be thinking, hey, these replacements look pretty small. What gives with that? Well, first let me tell you what I did. I replaced both the 10 megs and I replaced the 22 meg, and I did spot check some of the resistors around the focus control, and I checked the focus control. There's a string of 1.8 megs in here. They're all a little high, 2.2, 2.3. And the focus control does seem to work okay. We'll explore that further a bit later. And I also replaced the 0.1 microfarad coupling cap to the grid of the vertical amp tube. Now, as far as the resistors I used, they are not what they appear to be. There are a number of types, there are several types of resistors available on the market today. You can still get carbon comp, they do still make them, a little bit harder to find. So that's a possibility. Here's a modern 22 meg half-watt carbon comp. It's carbon film. There's metal oxide. There's metal film. And all of these follow that same deal with a half watts. Have 350 volt rating. 1 watters have 500 and 2 watters 750. And then there's these. They look like half watt resistors, but they're not. They are 1 watt resistors, metal film, but that's not what's important. What's important is they are the VR37 series made by Vishay. They are good for up to 3,700 volts. So even though they look like standard metal film resistors with the blue bodies, these are rated for high voltage applications, meaning that the material they're made out of and the coating they use can withstand much higher voltage than any of these. So that's what I used. And I will replace these 1.8 megs when I get some. Right now I only have carbon film. Save yourself some headache. I've worked on a lot of these electrostatic sets. Even though these may measure okay, they get weird over the years of having high voltage on them. In the case of this one that's open, I suspect maybe there was some corrosion or an arc occurred and it blew it open so that it's no longer conducting at all. Sometimes they develop carbon tracks inside that will only conduct when there's a lot of voltage across it. When you measure it with your ohm meter that only puts a few volts on it, they'll measure okay. When they're in the set, they start acting, they're not acting like they should be. So I'm going to order up. I don't have any VR37 1.8 megs on hand right now, so we'll just have to go with these. But I will be replacing them. So my advice to you, unless you want to have some fun troubleshooting and just see how it works as it is, just go ahead and replace. Every electrostatic set I've ever worked on had a string of these in the high voltage circuit to divide the voltage down for various elements. That's this whole string here. Just replace all of them with high voltage rated resistors. You'll save yourself some headaches. And the same goes, they almost all use a 6SL7, and they always have 2 resistors. So why would those 2 resistors matter? Well, I mean, having one open, of course, that could be affecting the deflection plate, because those 2 10 meg resistors go to the plates on the 6SL7 over here, and then it couples through these 2 caps and goes right to the vertical deflection plates. But if you look at these 2 10 meg resistors, they connect up to this string of high voltage resistors that works its way all the way back to the high voltage source. This is a huge voltage divider string terminating at that tube with the plate resistors. So with one of those resistors being open, this would have been drawing less current than it's supposed to, which would have affected the whole voltage divider string and the points all along in here, which could very well account for the focus being bad. Okay, so let's see what effect all those changes had. I did do some checking around the 6AL5 video detector and third eye F amp. No smoking guns. There are no paper caps that are coupling the signals. The resistors are all within spec. Tried swapping tubes, didn't make any difference, so the next thing would be open coils, which is not something I want to encounter, but it's about all that's left at this point. There we go. Well, that, aside from the hole being off, is looking a lot different and a lot better. It's still scrunched horribly, but much better contrast, much better focus. Focus control still isn't doing a whole lot, but it definitely has better focus. Now let's see about vertical centering controls. Before I couldn't get it to move down. Hey! Alright, so that's vertical centering and horizontal. So you have horrible linearity with the bottom being scrunched. There is no linearity control. So that is often affected by that 6SL7 tube. Sometimes you need to swap the tube. It can be very sensitive. Those two triodes in there need to be pretty evenly matched. As do the two plate resistors. Well, we already swapped those out, so those should be good now. Oh, and I did replace the coupling caps, because again, save yourself some headache. They're always bad. There's no way they're going to hold up to 6,000 volts after all these years. So that's exciting. We're definitely making some good progress here. Now back to troubleshooting the lack of reception. Well, rather than just guessing, how about we try to see the unseen? How do we do that? With a scope, of course. First thing I wanted to do was verify I'm actually getting a signal out of this jack. It turns out yes, but it's actually a lot weaker than I realized. So the points I was injecting earlier, like at the third IF stage, or the detector, turns out this was just too weak. So I went all the way to the grid of the first IF tube. There's 3 IF stages. So I'm on the grid of the first IF now. And what do you know? We have a decent image, and that's with this level all the way. So I don't remember this being so weak. But this does need some servicing. Or is the gain of this set just that miserable? Not sure, but hey, at least we are getting something through. So next I'm going to go one stage back and switch this from IF mode to RF mode and feed through right through the antenna terminals on channels 3 or 4 or 5, something like that, and see if we get a signal through. If we don't, problem could be in the tuner, or it could be a lack of gain in the IF stages. Now I'm going through the antenna terminals, but I left the generator in IF mode, and we're still getting an image. That's good. That means signal is getting through, and the IF is just making its way through the RF circuitry. So let's go to, I don't know. Channel 4. And we are seeing something. But is that just the IF leaking through, or is it actually receiving channel 4? Let's see. I think the tuner's on channel 4 now. I'm varying the output here. Terrible reception though. Well, if we're lucky, it's just because we have maybe a really bad tube in the tuner. The tuner is also filthy. These contacts could stand some cleaning. So I'm not in IF mode anymore, so it can't be IF leaking through, so it's got to be actually getting reception. So if I change the channel on this, it should go away. That's kind of weird no matter what channel I put this on. Unless I go in, well, channel 2 doesn't give anything but whether I'm on 3, 4, 6, 7, 8. Until you get to 12, and then finally it goes away. Well, let's try putting the tuner on channel 12, see if it comes back. No. Why No, I just hope it's not a case of this thing isn't working right. That should be on channel 4 now. Okay, not getting anything, nothing. I'm on channel 5 now with the tuner. Something's coming through. Oh, I'm on channel 4. Let's see if we can get that to lock. Not very easily. So yeah, something is getting through if I put the generator on maximum output level, which may be higher than my test pattern generator could, or maybe just in the course of tinkering with some other stuff we improve things. But that's terrible. That's terrible. Huh, that's a lot better. 3, 4. Oh, I was off. It's hard to read these, so there are... sorry for the crazy freehand camera work. There are these insertable modules for different channels. So 2 is realized, 3 is still like the next one in the chamber. 4 is the one that's engaged right now through these fingers up here. So, okay, and actually I can turn the output level down quite a bit and we still get decent reception. So why the heck wasn't this working earlier? As far as sound goes, there was just a buzz. And there is audio on off. If I turn it off, it changes. But it's not exactly a very pleasant tone. Oop. Maybe it's just dirty contacts. So an easy way to clean these is to take metal cleaner, semichrome, brasso, what have you, and go over these. I believe they are silver plated. See, channel 12 was pretty clean. That's how they should look. And notice how those fingers move up and down as I change channels. Yeah, you could spray contact cleaner in there too. Stuff like this. Or tuner cleaner if you have any. Haven't made it in a while. Could do have an old can lying around. Alright. Well, now that I've made you guys seasick, I'm going to clean the tuner and start checking some of these tubes so I'm not just chasing my tail here. Well, I checked all the tubes and was surprised to find only 2 that were weak. And probably not coincidentally, they were both Emerson tubes, probably the original. One is a sync limiter tube, I believe, and the other is a discriminator audio frequency amp, the 6S8. I put in 2 new old stock tubes to replace those, cleaned and lubed the tuner. I used good old deoxit, and boy, that that tuning drum was just filthy. Clean the tubes while I was at it, so now I'm going to flip the chassis down and hook up an over-the-air converter box and see if we can actually pick up a station. Before we get to that, I wanted to talk for a moment about what it has been like to work on this chassis. Not the easiest, not the worst. The most difficult thing has been some of the caps were a layer or 2 deep. I ended up replacing more caps than I really wanted to, simply because, for example, this yellow cap down in here, that is one of the vertical caps. I believe in order to get to it I had to replace or remove 2 other caps, and I figured, well, while I'm digging down in there, I might as well replace all of them. I connected an over-the-air converter box to the antenna terminals, reinstalled all the tubes, and I cleaned up the tube sockets while installing the tubes. So let's give this a try. Now, I do want to say, if I was restoring this for a customer, if I was on the clock for doing this, I would not have done it this way. The first thing I would have done would be to check all the tubes, clean all the tube sockets, clean all the controls, make sure all the wiring was sound. But if you want to have some fun and exercise your troubleshooting skills, I think it's more fun to just go with what's there and track down the problems one by one. Let's see. Don't know if I'm on the right channel. Hey, sound.
I support Tammy Duckworth because she's committed to building.
First responders, service, commitment, honor.
Free enough to slaughter and to burn all the things that had been built. I tried to break the chains of it.
Let's get the picture to hold. I turn the contrast up, that helps. Alright, Star Trek.
Every decent fun boy. You're coming back to pay for your and all those with whom you're plotting to take power permanently. When I return to Sharon, you will understand what power is. I will have armies of followers. It is now very clear that you know each other extremely well, gentlemen. The only service this ship can offer is to bring you together.
So it's good sound, but if there's a buzz, and if I turn the contrast up, the picture gets brighter, but the buzz gets way worse. Fine-tuning helps, but I'm going through the entire range of the fine-tuning, and it doesn't do a whole lot. So I have the contrast up all the way now, which you would normally never do. You would have it down pretty low. But it's still, it's bright enough to watch, but it's too much contrast. The details are washed out. But if I back it off, it gets too dim to watch.
Since I am without
the buzz diminishes.
I insist that you take us there immediately. Impossible. I have a mission to accomplish. There's a planet to be decontaminated. Millions of lives are at stake. Once that has been completed, I'll return to Starbase 4 and
strike a happy balance. And I think brightness is up all the way, so the interaction of brightness and contrast is not. Yeah, it's not so good. So that probably, well, I could think of a few things. One, that probably goes back to that high voltage divider chain with those resistors. I know a bunch of them are off value. That's going to affect the way the brightness control works to some extent. But this way, there's still a bunch of old caps in there, and there's still a bunch of resistors I haven't checked. And I know there's some that are a bit off value that I haven't replaced. All that being said, hey, it's working pretty well. Actually, the most annoying thing to me right now is the vertical linearity. It's still stretched out at the top and scrunched at the bottom, so let's go after that next. Since I have a scope out, we can get a scope and look at the sawtooth waveforms and the vertical deflection plates and take it from there. Well, here's the sawtooth going into the grid of the vertical output tube, and aside from my scope being jittery, that looks awfully good. If this was the source of the linearity problems, the top would be bent down or the bottom would be distorted. That's really good. So let's check the differential output of it. So that's the input, that's pin 1 of the 6SL7. And there are two outputs, and they should be inverted, or 180 degrees out of phase with each other. And that's what drives the two deflection plates. So let's check pins 2 and 5. Now that's going to be a pretty large voltage, so put my scope in the highest range I can and give this a try. It might be off scale. I'll tell you why in a moment. How good it fits. I think I'd wondered about this scope since I got it years ago, is why can't I go to the highest ranges for the vertical scale? I'm at 5 volts per division, but the knob goes up to 5, 20, 50, but I can't. I found out that if you have a real Tektronix probe, it has a little pin that sticks out that enables the vertical switch to go to those higher ranges. I don't. I have a cheap knockoff probe, and it doesn't have that feature, so that's why I can't get those ranges. Anyways, this looks pretty good. Now, there is a remote chance that the problem is with that CRT. That we can chuck easily enough by swapping another one. After all, the CRT was in pretty rough shape when I got it. Let's see, that's pin 2, pin 5 will be the other. 5. Oop. And where is that? Ooh. Well, there's your problem. What the heck? Ah. Well, maybe that's the problem. Here, look at this. Well, 1 step forward, 2 steps back. Fixed the vertical linearity problem, but now we have a green screen. I'll explain that in a moment. First, the linearity problem. So earlier I was focusing on the plate resistors on the 6SL7, which are unfortunately off the page to the right, and I replaced those to 10 meg, one of which was open, and they got the linearity, or sorry, they got the deflection pretty good, but linearity was way off. We looked at pin 5, and it was terrible, and I thought that maybe this resistor was a problem. Turned out it was 18 meg in this set, 22 meg on the SAMs. Maybe it was a production change, I don't know. But replacing that did nothing. And then I got to thinking, well, maybe the problem is actually in how this circuit works. It does a phase inversion, so the output of this tube, we have 2 plates 180 degrees out of phase. This is the stuff that does that. So 100 picofarad cap, a 0.005, and a 10K and a 10 meg. So I checked all that stuff. I replaced the 0.005 with a plastic film, and I discovered this was broken off. This is that 100 picofarad. I've seen this in a lot of these electrostatic sets. They have one of these tubular ceramic caps and the vertical circuitry. I get the impression they all borrowed some of these circuit designs from each other. It can't be a coincidence that they all use they all use a 6SL7, or an awful lot of them do, and they usually have one of these. These are very stable, but ceramic caps typically have a special temperature coefficient. Because you'd think they use mica, it's very stable, they have mica caps all throughout the circuit, but why is this ceramic tubular? Well, at any rate, either from me moving it, or maybe it was the way I got it, this lead was broken off. And there just wasn't enough of a stump for me to solder onto, so I threw in 100 picofarad mica for now. Seems to work fine. Hold on, we have some rolling now. I can take care of that. Now I do have another chassis that's in miserable shape, but I checked my reference photos I took when I got it, and it does have that part, so I can scavenge it out of it. So in a bit I'm going to go grab my other chassis and compare and contrast and steal parts where needed. So that got us great vertical linearity. So why is the screen green? Well, while fixing that, I turned the set back on, and the screen was blank. It seems this picture tube is no longer working. The filament glows, but just no image on the screen. So It could be that one of my connections broke off in the repaired base, or maybe it just finally gave out. I don't like that. I never did like that that getter is completely gone, so maybe enough air finally got inside that it's no longer functional. We'll have to examine that more later. Meanwhile, we can keep working on this. I noticed one other problem too. The plate load resistor on the vertical output tube should be 5.6. It was measuring about 16K, or about 3 times what it should be. Replaced it. Really didn't do much. I am still not at all happy with the brightness contrast. And this contrast control is very flaky. I've cleaned it, but it's still just... So I'm wondering, is the problem the circuitry, or is the problem with this control? This is with the contrast all the way up. That's pretty much the only way you can watch this set. If you turn it down, it's just too faint. But there is something else we can do. The high voltage is supposed to be 6,000 volts. We have about 4.7. There is an adjustment inside the high voltage box. There's a hole in the back, and there's a trimmer cap inside. And we are going to adjust that now to get 6,000 volts. That should give us a brighter image. So let's take care of that right now. Now, unfortunately, this is the best I can get where it was already set, about 4.7 kilovolts. There's the adjustment cap on the other side. Now on the service info they show a 500 picofarad high voltage filter cap right in that middle area. And it's missing from this, and there's a bit of a glob of wax. So I'm wondering, did that fail and just get removed, which could be affecting performance. And I also have to replace the electrolytics, and B plus is a bit low, which absolutely would affect this. So I'm not going to focus on it too much, but I want to show you with that shielding box off, you can see the incredible amount of interference. This box needs to be on, and all these screws around the top and the bottom really need to be tightened down to effectively shield it. As I got this, there was only one screw on the top, and that's how I've been running it all this time, so I'm sure there's some RF leaking out. Alright, well I'm going to pause now while I get my other chassis, because we have too many unanswered questions at this point. Hey, what do you know? The other set was here the whole time. I guess I convinced myself it wasn't here because I hadn't seen it in a while, but no, it's just on a shelf on the corner of the basement. So I got this at the very first Arky Radio Fest I went to years ago, and it's got some issues. So the chassis is rusty, especially in the tuner area, I think from rodent activity, and the cabinet is absolutely miserable because it was falling apart and somebody repaired it with what appears to be Gorilla Glue, which is a type of expanding foam combined with epoxy, or it's expanding polyurethane foam or something like that. Incredibly sticky, bonds to anything, virtually impossible to get off. So we'll deal with the cabinet another day, but yeah, this is what the set looks like. Some minor issues on the plastic with the reverse gold painting, but at least this is in pretty good shape, and I do have all the knobs. And it does have a picture tube, which I do believe tested good. So if I can't resurrect the one that I tried to put a base back onto, we can probably use this one. So I'm going to pull this out, compare and contrast to this guy, swap out parts as needed. And the more I think about it, the more I'm thinking I really need to get the other main filter capacitor replaced, because B plus is low in this set, and that's going to affect everything. So I replaced the filter cap right after the rectifier, and there's a filter choke and then another filter cap. That second one, I believe, is in here and has not been replaced. So let's replace that guy and get B plus up, which should, I hope, boost the high voltage. And I'm also curious to get the high voltage box off of this and see if it has a cap down in there that this one is missing. I replaced the second electrolytic, the one right after the filter choke, which got B plus up a little bit, got a little bit more high voltage, better looking picture. A moment ago I went to turn the set on to show you guys what it looks like now, but half the tubes didn't light up. It turns out that the 6SL7 bit the dust open heater. what happens with these series strung sets is when you turn them on, there's a surge current. The tube filaments, when they're cold, have less resistance. We're going to add a thermistor to help prevent that. A thermistor has the opposite property. When it's cold, it has a high resistance. I don't want any more tubes popping, but I will turn it on now just to show you, because we have a notable improvement in the screen image. So I'm happy with now with the brightness and the contrast, and the video quality is pretty good. Last thing I'm going to do is see if I can tackle the buzzing sound, and then I'll call this done for tonight, because I'm getting a little worn out. It's been a long night. Encountered a lot of problems I wasn't expecting. Alright, so now I'm going through the full contrast range. That's how it's supposed to work. You go fully left, it still locks, but it's washed out. And the higher you turn up the contrast, the more contrast you get. And as far as brightness goes, well, let's put the brightness in an awkward place on these sets. But now we have a really good brightness range. And yes, of course, it's a green, but we'll address that in a bit too. But the sound is absolute crap, so I want to take a look at that. The simplest thing to check is the tuner has adjustments for every channel slug. There's a hole right there. You can put a tool down which adjusts the trimmer slug inside of these. Maybe it's just off a bit. That's certainly a simple thing to try. Now, if that doesn't do it, coil slug top and bottom, and another one over here for the sound for the ratio detector. We can try tweaking those a little bit by ear. Sometimes they can eliminate the buzz by doing that without actually dragging out all the test equipment. Adjusting the tuner slug helped a bit. Adjusting the top of the sound coil helped a bit. Now let's try the bottom. Ooh.
Sometimes we ourselves out looking for that perfect person, and it turns out that they were right under our nose all along. That's right. Yeah. Well, then this could be the opportunity of a lifetime.
Oh, much better. Now, I need to get a proper RF generator, 4.5 megahertz, to do it and go through the procedure, but that is listenable now. Cool. So, next up I want to dig out my other chassis and swap out some parts. I want to try putting that picture tube in here, and a ceramic cap that I damaged, or is damaged, and I put a mica cap in its place. Oh, and then we can take a look inside a high voltage box and see if it looks any different than this one. Here is the other chassis. Not quite as bad as I remember it, but the tuner definitely has some heavy corrosion. And it is more all original, including one very bad 25L6. Toss that guy. Does have some original Emerson tubes. Might as well transfer these to the other side if they're good. $9.43, so I assume that's 1949, 43rd week. Oh, and there should be a shield on the CRT. Excellent. Very glad I dug this out, so we will transfer this, well, I'll transfer the entire CRT over. And there is a cap down in there. That may be a little hard to see, but there is a tubular cap next to that coil. So we're going to take the CRT out, and then I'll take out the screws around the bottom of the shield. We'll take a closer look at that and see if I have something compatible. I think I do have some ceramic caps of that similar capacitance that has enough of a voltage rating. Also curious to see how the twin lead is taped down over this cap. It's different on the other set. Either the tape's gone or maybe they replaced the twin lead. Somebody was definitely tinkering with the tuner on that other set. Perhaps because, well, it's got dirty contacts, or had dirty contacts. Ooh, this one's a little gummed up too. Alright, how about under the chassis? Yeah, I think this is 100% original, so I'm going to leave it this way and use it as a further guide if needed for the other set. Boy, it was a surge limiting resistor. I think it's supposed to be 2.5 ohms. That's pretty well corroded. That's what the original high voltage coupling caps look like and how they were routed. I don't know if that's the best way to do it, running the wires just right up against the body of that, considering there's quite a bit of voltage on that cap. Especially the outer, which is ground, assuming they grounded the outer foil of it, and you've got about 5,000 or 6,000 volts on that wire, so that seems a little dicey. And there is that tubular ceramic cap that I want to salvage and transfer over. There's one resistor I was wondering about. This has an 18 meg. I put a 22 meg in the other set, but maybe I should replace that with an 18. And you can see the bumblebees, that's what happens to them over time. The paper caps inside these plastic tubes start swelling and the plastic cracks open. Alrighty, this is a luxury. It's not often you have two identical chassis, one of which is all original, which you can use as a reference. As for the cabinet, this is maybe the most miserable cabinet I've seen in a while. Hey, there's a chunk of it just fell off. Not only did somebody Gorilla Glue it, I think they just painted it with polyurethane. Some areas it has it, some areas it's missing. But clearly this thing was exposed to a lot of moisture and it's just delaminating like crazy. Honestly, I don't think this is really worth putting any effort into salvage-wise. Maybe just glue it up so I can put a chassis in and put it on a shelf for the time being, but eventually I think I should just build a new one from scratch. That's a plywood box, it's not that complicated. With veneer on over the box, and then the front I can salvage. The plastic for sure, and hopefully the beveled surround. So I've been wanting to, I was going to say improve my cabinetry skills, but actually maybe develop some at all because I don't really have any. I did pick up a table saw that I've barely used. I could probably pick up a router. And I have some projects in mind for the future, some cabinets I would like to fabricate from scratch. I think this would be a good place to start because I have a model. All I need to do is clone this. Eventually I need to also make a new cabinet for my Scott 6T11, and then there are some, well, some other projects I have in mind down the road. All I need to do is pick up some decent grade plywood. Looks like it's about 1/4 of an inch thick. How hard can it be? Just cut up a lot of poplar strips for reinforcement, and away we go. And then of course veneer it. It's mahogany. I'm sure it's mahogany veneer. Oh, it's been an interesting salvage operation. Almost all the tubes are Emerson branded. Tough to see on these glass tubes because they use a type of white ink that really rubs off easily. And some of these are yellow. Some are white or bluish. One color or the other may indicate that those were replaced, maybe by the dealer. Who knows? 3 tubes are not original. A Tungsol 25L6 and the 2 tubes in the tuner. Even the CRT is Emerson branded. And it was pretty tough to get out because it had, well, probably been in this set since it was made, and a little stubborn. And the chassis is pretty bad. Now that I've gotten some of the parts out of the way, there is more corrosion than I saw initially, and there's mold and mildew on the cardboard, on the caps, so yeah, it's pretty nasty. I just removed or loosened up all the screws around the bottom of this high voltage cover, so it should come off. They're not easy to get at with all these components in the way. And I will transfer all these to the other because the other is missing some of these screws. There we go. And I will certainly hang on to that coil because those are hard to find replacements for. So there is that cap down in there. Boy, it was just covered in filth. I can't see any value on it. Hey, even the high voltage rectifier tube is an Emerson. How about that? So I will work on that to extricate that and all the other parts that I want to salvage. High voltage circuits tend to attract fine particles from the air, and this is no exception. That's why it was so dirty looking. I scraped that away, and yeah, it is a 0.0005 microfarad 6,000 volt cap, otherwise known as 500 picofarad. Well, here is a modern 560 picofarad 6 kilovolt ceramic cap, so I will install that. I could see little traces of where it used to be on this. It needs to attach to a pin underneath the high voltage tube socket and then over to, I believe it's this point. And while I'm in here, there are a handful of resistors. I'll just go ahead and replace those while I got it open. And then I will put the cover back on, seal it all up with all the screws, and that should be good. And also, take out this green CRT and swap it out with the other. I'm a little bummed. It's cool to have the original Emerson with the Emerson logo, but it also means it's the original picture tube, so it may have a lot of hours on it. But we'll see. Maybe we get lucky and it's a low-hour set. Well, some good news, maybe. I touched up solder on the pins of the CRT, the 7JP4 that I had to reattach the base to, and I do have an image back, and it's not too bad. But I did notice on the neck, I don't know if the camera can pick this up. Yeah, I think it can. There is some funkiness. There's a purplish streak in there. Now that might be some stray electrons hitting glass, which is not a problem. So we have nothing to lose, so we'll use this. It's just a hassle that I have to go through and unmount the other CRT and remount this one. And then if it was to die on me, I would not be too happy. It certainly produces a better image, so that's the important thing. I removed the picture tube from the other chassis, cleaned it up, installed it on this chassis with the shielding and such. So let's see how it actually works. Hold this horribly off. It's kind of odd because it was locked in with the last picture tube. That's not very promising looking. Wow, that is what a extremely worn out picture tube looks like. Basically, the everything gets inverted. I shouldn't be laughing. That's bad. There's no fix for that, other than to use a different picture tube. You can't rebuild. You can't rejuvenate 7JP4s. So I just turned the brightness way down. Turn the. Yeah, I've seen worn out 7JP4s before. This is about the worst I've seen. So if you're in a really dark room and you turn the brightness down really low and get the contrast set just right, you can kind of sort of watch it. Well, I hooked up this old worn out CRT to my Sencor CR70, which does support the 7JP4. Tested fine, great emissions, great cutoff. As we know, it's producing a terrible washed out image. So I did hit rejuvenate. And it is brighter now, but I can't get a watchable image out of it. It's too washed out. The brightness control doesn't seem to do anything anymore, or has very little effect. There is a remote possibility that when I took the connector off and back on, I damaged something, or I made the picture tube even worse by trying to rejuvenate it, which is a definite possibility. Well, to rule that out, let's go back and swap out the picture tube yet again with something else. I dug up a 560 picofarad 6,000 volt cap, installed it down by the rectifier there. I have the picture tube with the reattached base installed, transfer the shield from the other CRT. Let's do a little bit of work underneath and wrap this project up for now. Alright, adding a thermistor. Well, this is the main power supply area, the old selenium rectifier, filter choke, a couple filter caps, the death cap, the across the line filter cap, I've replaced that. There's a new silicon power rectifier to replace this. There was an existing resistor that actually fell apart. It's supposed to be about 2 ohms. I think I have a 1.5 in there now, just a little bit of surge limiter. Well, this whole area should be cleaned up. All this should be taken out, a nice terminal strip installed. Good mounting point here if I take out the selenium rectifier, because it'll free up space and it'll give me a hole. And I can see there's another hole existing right here, so I can mount a terminal strip somewhere in there. But meanwhile, we have a terminal strip here with just 2 lugs on it. Well, one of them goes, as a black wire, goes right over to the AC line, and the other side goes to this wire, which leads up to the filament string. It took me a while to trace that out. It actually goes up into the tuner. That's where the filament series string starts. And the other goes to that surge limiter that goes to the B+ supply. So alright, this is the power supply area, which is a little ugly for me tacking in new parts. Really what needs to be done to make this safe and secure is to remove this, which will free up a lot of space, and then install a nice new terminal strip down here with half a dozen or so lugs to mount this stuff. There is an existing unused hole over here, and if we take this out, that'll free up a hole of plenty of space. Here are 2 new caps I tacked in to replace that guy. We have a few resistors. This 1K is way off spec. It's almost 2K. The 75 ohm actually feeds the high voltage generator. I was hoping that this had drifted up in value, because that would account for the high voltage being a little low. Maybe there's some other stuff at play here. There are still some old parts down in there I haven't replaced yet. We have a death cap, across the line cap here. I have replaced it. It was a paper cap. I have a Type X safety cap in there, Type X2 to be specific. This is the power silicon rectifier to replace the selenium 1N5408. And they had a surge limiting resistor in here, I think it was 2.2 ohms. It basically fell apart. I put in I think it's a 1.5 ohm resistor. Alright, having stuff floating in free space like this is a really bad idea. Things can short together. I just cut off the old lugs off that electrolytic, and that's what I tacked the new ones onto. This has got to go. But not right now. Right now, I just want to throw in a thermistor to give you an idea of the effect it has. later on when I have more time, I'll go through and redo all of that. So this is what I'm going to use. It is related to the CL90, which is a classic thermistor, been around for forever. This is just a little bit smaller form factor. With newer suppliers, they offer some of the more classic ones, like the CL90, in several package styles. The smaller ones have a faster warm-up time because they have less surface area. These work by temperature. The resistance varies with temperature. So the smaller ones heat up faster. I just happen to have a bunch of these, that's why I'm using it. So this is 120 ohms, approximately, at room temperature. When you've got about 1 amp steady going through it, it drops to 3 or 4 ohms, which is pretty close to what that guy is. And we do have a little bit higher line voltages. This was designed for around 117, so I'm good with that. But where do we put it? Again, don't have a good terminal strip. There's only one terminal strip here. It only has 2 lugs, and they're both used for different functions. But I can tell you that this lug right here, that is the AC coming in, one side of it. The unswitched side. That's a black wire here, goes right to the AC interlock. We've got our across-the-line cap going there. We've got our surge limiter resistor here, and we've got this wire going up to the filament string. I could just put the thermistor in line with the tube filaments, which draws 0.6 amps. I'd rather just put it on the entire set, which means I could eliminate that. And we'll have about an amp going through it. So what I'm going to do just for now is disconnect both this wire and this power resistor and attach one leg of this to that lug and connect these two in free space to the other lead on this, and we'll spread them apart. Just want to see what kind of effect it has. It should power up a little more slowly. The tube filaments take a little bit longer to get to full operating temperature, which is the whole point. We want to give it a soft start. It'll take a few seconds longer for the set to actually come on, but that's okay. It saves stress and wear and tear on the old parts. I just finished completely rebuilding the power supply in this area. I removed the selenium rectifier, made use of an existing hole to mount terminal strip, replaced that selenium with this 1N5408 silicon diode. These 2 electrolytics, replaced the 2-section electrolytic back here, replaced the wax death cap, so-called, that goes across the AC line with this guy. It's a Type X2 safety cap, rated for AC operation, and I added a thermistor. So the AC comes in right on this black wire, goes to this thermistor, which then branches off to the filament string and to B+. So this thermistor is protecting the entire set. I mounted it away from anything because it's going to get a little toasty, so it's off there on its own. I think that about does it. This area is a little ugly. I'll redo this later on when I get those high voltage resistors in. I want to redo this whole string, and at that time I'll mount these more securely, but that is it for me tonight. I am really burned out, so let's pop this back in the cabinet and give it one last look in operation. I have this set back in the cabinet. Let's take one final look at it playing back together. This project had a lot of twists and turns I was not expecting. In the end, I'm very happy with the way it went. Often it's tough to get, or you don't get the incremental improvements you think you might as you replace a part, power back up, replace or power back up. Because TV circuits are often very interrelated, and having a problem in one circuit may, or fixing a problem in one circuit may actually make another circuit work not as well or not the way you expected. But in this case, yeah, that was kind of cool to see. So what just happened now? You saw that spark and things kind of collapsed. that was some corona discharge. So those new high voltage caps I just tacked in, that's what'll happen. I need to dress all those leads neatly, use round solder joints, no sharp points, maybe put a little corona dope here and there, but that's what happens with these sets. It's not at all unusual.
Hey, Mr. Dorian.
Fantastic sound.
The bottle in the surf.
Pretty good picture, all things considered. Seeing as how we had well, this picture tube was a mess, and the one that came with this was completely shot. And my rejuvenation attempts made things worse. I do regret that a little bit. But overall, hey. The main reason I was working on this is I was waiting for some predictor parts to show up because I ran out. They will be arriving tomorrow, and it's going to be wall-to-wall predictors for a while. I have a bunch of those to get to. But meanwhile, I hope you guys enjoyed this rather strange journey to get an Emerson 639 more or less working. At some point in the future, I will get back to it, neaten up my work, and then see what we can do about this cabinet. Thanks for watching.